Good morning to one and all. In today's lecture, we'll discuss about the M-array frequency shift keying. In M-array frequency shift keying, where M is equals to your modulation order, or we can say the number of possible signals. Here, I will be considering your BFSK, that is your binary frequency shift keying, where your M will be equals to 2, because for binary, your M will be equals to 2. So for BFSK, we will be considering two signals only. So first is your x1t, that is equals to a cos 2 pi f1t. Similarly, your x2t, that is equals to a cos 2 pi f2t. If I want to represent this amplitude in terms of energy per bit, so we can represent it as under root of 2EB upon TB cos 2 pi f1t for x1t, and for x2t it will be equals to under root of 2EB upon TB cos 2 pi f2t. Here your x1t will be representing your bit 1 and x2t will be representing your bit 0. So the basic formula will be k is equals to log base 2 into m, where k is equals to number of bit per symbol and m is your modulation. Now for example, if I consider that when your k is equals to 2, when your k will be equals to 2, then your m will be equals to 4. Similarly, if I consider your k is equals to 3, then your m will be equals to 8. Now, if we talk about the generalized equation for MFSK, for MFSK it is xit is equals to a cos 2 pi fit, where I represents your ith symbol, where I varies from 1 to n. Now here fi will be your ith symbol frequency. Now see, if we talk about the time period in MFSK, the time period will be associated with the symbol, not with the bit. So we can say in BFSK, here the time duration was between 0 to TB. Your time period was between 0 to TB, where TB represents your bit duration. But in case of FSK, this is the basic difference between your BFSK and MFSK. Here your time duration will be limited from 0 to T, where T represents your symbol duration. Now if we see here, your Fi, that is the ith symbol frequency, will be equals to your Fc plus 2i minus 1 minus m into Fd, where Fi is equals to frequency of your ith signal and Fc is the center frequency. Fd represents your frequency deviation. Now, if we consider an example, if we want to calculate, we have a 4FSK, where your center frequency is given, that is 250 kilohertz. Frequency deviation is given, that is 25 kilohertz. Now, suppose if we want to identify that how many frequencies are there with different symbols, so how we will be able to represent your number of bits per symbol. So for that we will be calculating. Now we know m is equals to 4. Here your m is equals to 4. We know that k is equals to, we know the formula that k is equals to log base 2 into m. That means log base 2, we know the value of m, that is 4. We can put 4, it will be equals to your 2 bits per symbol. Now for calculating the frequencies, here we know the formula, that is Fi is equals to Fc plus 2i minus 1 minus m into Fd. We know this formula. We know the center frequency, it is already given. Frequency deviation is given. So we can easily calculate the 4 frequencies, that is F1, F2, F3 and F4. So your Fc, that is 250 plus 2 into I is your F. For F1 it will be 1 minus 1. Your m is equals to 4. So putting 4 over here, and Fd is 25. So by this we can easily calculate, it will be equals to your 175 kilohertz. Similarly for F2, your Fc is 250 plus 2 into I is 2 minus 1 minus 4 into 25, that is equals to 225 kilohertz. Now for F3 frequency, it will be 250 plus 2 into 3 minus 1 minus 4 into 25, that will be equals to 275 kilohertz. For F3 it is 250 plus 2 into 4 minus 1 minus 4 into 25, that is equals to 325 kilohertz. So by this we can calculate the frequencies. Now if we say that how many bits per symbol, we have to represent the number of bits per symbol. Now see, we k is equals to 2 bits per symbol, that means each frequency will be having 2 bits per symbol. So bits will be 0 0 0 1 1 0 and 1 1. This will be your bits per symbol. So this is how we can calculate the frequencies, the different frequency along with the number of bits per symbol. From here we can see that at the transmitter and receiver side we will be needing 4 local oscillator. So it increases the cost and complexity of the system. This is basically widely used in your frequency hopping spread spectrum, that is your FHSS. The basic application of your MFSK is your Bluetooth. So this was all about your MFSK. So what we did, just memorize it. I'll be summarizing it once more. Here M is representing the modulation order, we can say the number of possible signals. If we consider BFSK, that is your binary frequency shift keying, where M is equals to 2, will be having 2 signals, that is X1T and X2T. We have represented in terms of your energy per bit symbol. The basic formula is that K is equals to log base 2 into M, where K represents your number of bits per symbol and M is your modulation. Now if we talk about your MFSK, here your XIT will be equals to A cos 2 pi FIT, where I represents your ith symbol and Fi represents your ith symbol frequency. Here Fi is equals to Fc plus 2i minus 1 minus M into Ft. This is basically the formula, where Fi represents the frequency of ith signal, Fc is your center frequency and Fd is your frequency deviation. Based on this, we have calculated, we have been given in the question that we have to calculate the number of frequency that is being used for different symbols and how we can represent the number of bit per symbol. So what we did, we know the basic formula that K is equals to log base 2 into M. We know M is equals to 4. When M is equals to 4, it will be equals to 2 bits per symbol. We have calculated the different frequencies for F1, F2, F3 and F4. Along with respect to that, we have given the number of bits per symbol. So this was all about the MFSK. Thank you.